Hi, I'm Ben McFarland, Professor of Biochemistry at Seattle Pacific University, and I'm going to talk about the periodic table and its natural history. Now, chemists know that the periodic table of elements has not changed over time, but the number of elements and how much they are available in the environment has changed over time. You can look at it as the environment edits the periodic table, and that also changes over time so that different elements are available at different times. Since there are chemical rules which say which elements are used by life and how they are used, that means that as the planet processed these elements, the planet acted as a chemical reactor when all of the matter combines together. And that actually constrained what could happen in biology. And you can see these effects today. For example, one chemical rule is that the more soluble an element is, the more available it is, the different kinds of biological function it can be used for. So for example, if you looked at the most concentrated elements in the ocean today, the most concentrated elements are used for biochemical balance or biochemical building. The biochemical balance is shown in red, and you can see that those are colored red on top of this graph. Now the ones that are used for both balance and building are shown in yellow, and then if you look farther down on the graph, you can see that less soluble elements are used for building alone. This includes carbon, nitrogen, and oxygen. As you move farther down on the graph, you see even less soluble elements. These don't dissolve very well in the ocean at all. These are used for biochemistry. And you can see that I've colored those in blue. And when you go down below the 10 to the minus 9th level of solubility, you actually end up with elements that are too scarce for life to use at all. The other thing you can see on this graph is that there's many elements at the bottom of it that have arrows. They've moved up and down to where they are too scarce for life or they are plentiful enough for life. And so as this happened, the periodic table changed in its emphasis. So the biochemical periodic table, as a biochemist, I only have to use about 24 elements. A chemist can use all 118. Over time in the atmosphere, these elements were actually changed in emphasis. So one of the things that happened is hydrogen decreased in the atmosphere and oxygen increased. This changed the chemical nature of the atmosphere, and this affected the oxygen-sensitive elements as well. And in particular, you can see that there are a lot of blue biochemical catalysis elements that are on the first row of the periodic table. And it turns out that the general trend is as the planet oxidized, the ones on the left diminished in importance, those on the right increased in importance. And that means that older organisms will use the ones on the left, newer organisms will use the ones on the right more. There's a lot more to this story, but the important thing about it is that it was actually predicted by a chemist before it was proved by the biologists. In the 1990s, the inorganic chemist Rjp Williams took what he knew about the periodic table and he said, I think this happened in natural history. In the past decade, genomic data has confirmed his hypothesis. And so this is a case where the chemistry constrains what the biology can do. There is a lot more to this story because it's 4 billion years old, and it's a long story to tell, and so I told it in a book. And so I published this book, A World from Dust, by Oxford University Press. And so you can look up this book at oup.com. You can also look up resources at benmcfarland.com. What this book leads up to is a big question. There's a kind that science can address. Does this predictable chemical sequence, does this mean that the intelligence is predictable or not? If we rewound the tape of life, would we end up with the same human intelligence, or would we not? The chemistry is predictable, but the biology may not be so much. So if you're interested in asking these questions or seeing more detail about this story, I invite you to pick up this book.